Welcome to another walkthrough practice problem by physacademy.com. In this video, we'll practice almost all of the fundamentals of a ray optics problem. We'll learn how to sketch a complete ray diagram to get full credit in our exams, and also how to predict and then calculate the image location and magnification. An owl is sitting, as shown, in front of a diverging lens with the pictured focal points. Part A. Using the provided optical axis, or a good copy, carefully and precisely draw a ray diagram to find the location of the owl's image. Use a straight edge. Indicate where the image appears. Part B. Is the image real or virtual? Explain how you determined this. Part C. Estimate the magnification of the image. Part D. The owl is sitting 80 centimeters from the lens, which has a focal length of 50 centimeters. Using the math representation, find the location of the image. Part E. Using the math representation, find the magnification of the image. In Part A, we will sketch a complete ray diagram with all of the components of a full credit work. First, I start by sketching the main components of the ray diagram. The main axis is a straight line that goes through the middle of the thin lens. Then, sketch the lens like a straight line perpendicular to the main axis. The focal points are on both sides of the thin lens, and their distance to the lens has to be the same. So try to be as accurate as possible. Then sketch an arrow pointing up instead of the owl. An arrow is the standard symbol of the object in a ray diagram. Then sketch an eye on the other side. This side view of an eye, which is kind of creepy, is the standard symbol of an observer. Then, we start with ray number 1. This ray always starts from the object's tip and goes straight through the point that the main axis and lens cross. Be careful, ray 1 doesn't bend or anything, it goes straight. Ray 2 always starts from the tip of the object, and it is aimed toward the focal point on the opposite side for a diverging lens. But right as it gets to the lens, it bends and then continues straight parallel to the main axis. Always extend this ray to the left-hand side, like what I have here. The third ray starts from the tip of the object and goes straight parallel to the main axis. When it hits the lens, for a diverging lens, it bends up, but its extension on the left-hand side is toward the focal point, as I have it here. Then, look up for the point where all three rays cross. In this case, on the left-hand side of the lens, between the object and the lens, this point is located. This is where the image will form. Sketch an arrow and mark it as the image. Alright, this is a full credit ray diagram. It has our three standard rays and everything else, plus their labels. Part B. Is the image real or virtual? Explain. When an object and its image are on the same side of the lens, which is the case here, we have a virtual image. In Part C, we are asked to guess the magnification. From checking the ray diagram, since the object and image are both upward, in other words, both are pointed in the same direction, we expect a positive magnification. Also, as you see, the length of the image is about 40% of the object, so the magnification should be about positive 0.4. In Part D, the owl's distance from the thin lens is 80 centimeters, and the focal length of the thin lens is 50 centimeters. Calculate the image distance to the lens. Let's start with writing down the thin lens's equation. Here df is the focal length, which is negative 50 centimeters. Negative 50 is because here we have a diverging lens. The focal length is positive for converging lenses, and for diverging lenses, it is negative. D object is 80 centimeters. Remember, the D object is always positive. And we are asked to calculate the D image. Let's rearrange this equation. Then plug the numbers in. We get about negative 30.769 centimeters. Remember, we know a virtual image has a negative distance, so we expected a negative value. In Part E, we are asked to calculate the magnification rate. We start with writing down the magnification rate equation. Then we plug in the values. D, image or the distance from the lens to the image is negative 30.769 centimeters, and D, object is positive 50 centimeters. After this, we get a plus 0.385. Let's check our answer. Since the image and the object are both on top and pointed in the same direction, in other words, the image is upright with respect to the object, we were expecting a positive value for the magnification. Also, we expected a number below 1 for the magnification since the image is shorter than the object. Thank you very much for watching this video. Please check our website, physacademy.com, or our YouTube channel for more practice problems. If you found it helpful, by subscribing to our channel, you can provide the best support for our work.